Lesson we'll be doing a review of relations, and we'll get to the definition of relation shortly. Before we talk about relations, we're going to go ahead and talk about the Cartesian plane. The Cartesian plane is just the intersection of a horizontal number line, which is called the x-axis. So here's the x-axis, and a vertical number line, which is the y-axis. So we have the x-axis and the y-axis. They intersect at the zeros, and that point where they intersect is called the origin. As you notice, if you look at these axes here, they're called axes. They split the plane into 4 parts, and I've numbered them there. They're called quadrants. So we have the first quadrant is at the top right, and then you go counterclockwise. So you have your second, third, and fourth quadrant. Points on the graph. So a Cartesian plane is used to find location of points in 2 dimensions rather than just 1 dimension as you would for a number line. So they are named by ordered pairs x, y. And we'll go right ahead to this next one. The x values tell us the horizontal distance from the origin, and the y values tell us the vertical distance from the origin. So we'll graph a couple points here in our example. We have point A, that's at -2, 4. Well, that tells us we're at -2 from the origin horizontally, so we'll come back to -2, and then we'll come up 4 because of the y value there. So 1, 2, 3, 4. So our point A is right there at -2, 4. Point B is at 6, 5. So we're going to count 1, 2, 3, 4, 5, 6 from the origin. That's our horizontal distance. And then our vertical distance is -5. So we go down 5. 1, 2, 3, 4, 5. And here is point B. And then lastly, 0, 7. Well, 0 tells us we don't go left or right at all from the origin. So no left or right, and then we just go up 7. 1, 2, 3, 4, 5, 6, and 7. So there's point C. And that's how you graph points, which is a review for you, I'm sure. So here's the definition of a relation. It's any set of ordered pairs. So we have a couple examples of relations here. This first one uses numbers in their ordered pairs. So 2, 9. -1, 8, 16, 211. There's 3 points as part of that relation. There's another relation that doesn't have anything to do with numbers, but it's cat, kitten, dog, puppy, and bear, cub. Relations can have a finite or an infinite number of pairs. So in our example up here, this has a finite number of pairs. There's a countable amount. In other examples, we'll have an infinite number because it will keep going and going. Many relations can be written as an equation, and those really are the ones that we're going to be working with throughout Algebra 2, ones that can be written as equations. Here we're going to help us think about dependent and independent variables. If an ordered pair is x, y, and there's a relationship between x and y described by this equation, so I just mentioned we could have equations, y equals x squared, then you can find many ordered pairs if you pick some values for x and find their corresponding y values. And we'll do that later, but I'll show you really quickly here. We might say, okay, well, I'm going to choose values for x and find out what y is. If I choose, so I'm using this right here, if I choose, I want x to be -4, y, I'm going to put -4 in for x, and -4 squared is 16. So I would have the point -4, 16. And I could do that with an innumerable amount of numbers. In this, we plugged in -x, and y depends on whatever we chose for x. So y is called the dependent variable, because it depends on x, and x is independent. It didn't depend on anything. It's the independent variable. A couple more important terms here, domain and range. If you have a relation, the domain is the set of x values of that relation. So you can, it's a set, so you can put it in brackets or braces. So you could have the set of x values, and you would put the set of x values in there, and then the range is the set of y values of the relation. So here in this next example, we have relation A, it's called A, and that consists of the point negative, or 2, 4, and then negative 3, 7, negative 2, 5, 12, 4. So it has 4 points. We want to state the domain. So the domain is a set. It's the set of x values. And so we're going to list the x values. We have a 2, negative 3, negative 2, and 12. I'm just looking here at these x values. So that's the domain. Oftentimes we like to write it with the domain in order. So that would, our lowest number is negative 3, then negative 2, then 2, and 12. So both of those are domain. The second one's the better way to write it. And then the range, that's also a set. So we're going to use brackets for that. And in our range, let's go ahead and list those in order. I see my lowest value is a 4, and it's actually there twice, but I only have to list it once. And then next I see we have a 5, and then a 7. And so the range is 4, 5, 7. And again, there was 2 4s, but we only had to list one of them. And now we're going to look at different ways to represent a relation. So first of all, there's the list of ordered pairs. And so I should have braces here to show that it's a set of ordered pairs. It's a relation. So we have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, and 4. So that's my first way, just to list the ordered pairs. I also can have an equation, and this is, all of these are related. These 5 ways to represent a relation, they're all the same relation. And I mentioned before we could use an equation. Now, if you have an equation and then the domain here is listed, that relation only has those values in it. So here we see that y equals x squared, and we would only have negative 2, negative 1, 0, 1, and 2 as our domain. And we could then find a range, and so that actually brings us to another way of representing a relation, is this table. These domain values are right here in the x's. And then we see here the y values would be our range. And so if we put negative 2 in, we would get 4. If you put negative 1 in, you would get 1. So negative 1. So looking at the equation here, negative 1 squared is just 1. 0 squared is 0. And so we get those, which looks really close to our list of ordered pairs, because here they are, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Next we have a mapping. A mapping, or a circle mapping. You have a circle, or in this case I have an oval, and I have a D under here because this is my domain. And so notice all the values of the domain are listed. You can see them in our list of ordered pairs. You can see them written over here, or you can even see them in our x values. But here's the domain values. I then have the range values. 0, 1, and 4 are the only range values that show up. And then you draw an arrow from the domain value to its corresponding range value. So negative 2 was paired with 4. Negative 1 went with 1. I also want to skip down here and notice 2 was also paired with 4. So we have 2 things pointing at 4. And the last way is a graph. And so for this graph, what we did was we took these points listed here and we graphed them. So we had negative 2, 4, that's negative 2, 1, 2, 3, 4, that's negative 2, 4. Negative 1, 1, that's this point. 1, 1, or 0, 0, 1, 1, and 2, 4. Now notice this graph doesn't have a curve connecting all those points, because the graph of this relation is only those 5 points. We know that because it listed our domain. If there was no domain listed, we would then assume the domain was all numbers, and we would connect that. But if the domain's listed, or if it's just a list of ordered pairs, you do not connect the points with a curve. And so that's your introduction to relations.